we've done a couple of weekends of testing on the building now. We've done pressure diagnostics this weekend using the blower door and the duct blower so that we can pressurize ducting systems. We've learned a lot about this building already, and what we'd like to do is present to you a very brief summary segment of the things we've learned right now. So here goes a few minutes of what we've learned so far. We've set up a blower door, which is a large calibrated fan that fits in an adjustable frame with a Dacron cover so that we can actually have a closed door with a fan system in it. This allows us now to either depressurize or pressurize the building, know how much flow is going through the fan, and understand what the leakage characteristics of the building are. So we're actually going to turn on the fan controller and start moving air out of this building. As we took the reading on this building, we were able to get it up to about 25-30 pascals. So this building is so leaky that this fan doesn't have the capacity to move enough air to create a 50 pascal pressure differential between inside and out. So we use a mathematical formula to calculate what the leakage would be if we were able to move that much air. We've determined that this building has a leakage rate of about 0.81 air changes per hour. About 80% of the air is exchanged with outside air every hour in this building. That's a lot of air leakage. We think that there's a real opportunity to save money by doing some air sealing in this building. This is the return duct in the ceiling, and we've got enough leakage that we're actually pulling air from outside through the ducting system and into the building, okay, using the blower door. The furnace system is not operating at all. This is just pressure caused by a fan that's blowing air out through the front door of the building, sucking air in from leaks in the ducting system. And we can test to see if we've got the same thing in the supplies. We have a supply duct right down here. Let me move over there and we'll see what we have in this supply. Again, looking at this supply, it's clear that we have some pretty substantial leakage associated with this ducting system. This is caused by the blower door depressurizing the building, not by the ducting system operating. We did our initial blower door test. We had the registers were open, they were not taped off. Then we wanted to make a comparison and see how much of the leakage that we experienced in the building was actually associated with duct leakage. So we came in and taped over all of the supply registers, and we taped over all of the return registers, which are high in the system on the ceiling, in the entire building. Now that we've taped over the entire ducting system and isolated the registers, we're going to run another blower door test to find out how much difference that made in our actual leakage rate. We've done another blower door test with all of the registers taped off and calculated the amount of leakage we have and did the math necessary to understand the air changes per hour. We found that with all of the registers taped off and the ducting systems isolated, we've dropped from 0.81 air changes an hour to 0.56 air changes per hour. Mathematically, that turns out to be almost 30% of the leakage in this building can be attributed to leaks in the ducting system. So we have hooked up the duct blaster to one of the furnace systems that serves the west end of the building above. This is down in the basement. We've got two furnaces that are teamed together to blow into a supply plenum that's above the two of them and suck back from a return system that's connected to the two of them. So we're actually going to try to pressurize this ducting system. We want to measure in this digital manometer the pressure that's in the ducting system in our A channel and the flow rate in our B channel. We want to be able to create a pressure differential between this room where we're standing and the ducts of 25 pascals ideally, and then measure the flow. So we're going to crank this up and see what we've got. With the fan on as hard as it'll go, we're getting a pressure of 6.9 pascals and a flow rate of about 2,120. So with these ducts leak enough that we're not actually able to create a pressure differential of 25 because we have so much leakage. We can mathematically extrapolate what the leakage would be if we could reach 25, but we know that these ducts, we now know that they leak pretty badly, and there's a real opportunity to seal them. What we'd like to do is use the theatrical fogger to blow smoke into the system and go upstairs and see if we can figure out, both upstairs and downstairs, and see if we can figure out where the leaks are.
That came from there, this part. I thought I saw something.
Out through all these, every seam and every crack of this ducting system is leaking. Yeah.
Look at the smoke in the room.
Yeah, we're filling the room up with smoke within minutes, simply because of the leaks within seconds. Each one of these channel drives allows leakage. These are not airtight. As we come upstairs, these can lights are connected to the attic. So what this is showing us is that this system is filling the attic up with smoke within seconds and blowing it back down these can lights. We've taped off these registers that are on the front of the stage so that we could seal off the ducting system so that we can do duct testing, duct pressure testing. So with these sealed off, understand that this entire stage area is being used as a return plenum to suck air back to the furnace, which is over in the corner in a closet behind these cabinets in the corner. And we're going to move over there and look at the furnace itself, but this entire space here now is being used as a return plenum.
We didn't really get a reading on this.
Oh, we've come back in, or tell me whenever you're ready.
Go ahead.
We've come back into the actual area where the furnace is. We've opened up the fan housing of the furnace and we're looking down below it back into the area that exists underneath the stage. And you can see that back on the north wall, which is kind of to the left there, the studs of the exterior wall are exposed and open. There's no the insulation that's been in there has fallen out. It's actually allowing air to be pulled down that exterior wall into the furnace as well. And as we go further back in underneath this area, we're connected to wall sections that actually are connected directly to the attic. So this entire plenum system is a leak connected to outside. You can see right over here where I'm shining my light is the disconnected piece of flex duct that we're going to have to reconnect and seal. Now I've moved over here to the west, and what I'm finding is a soffit that's constructed into the ceiling below, designed to carry the cabinets in the kitchen area that's on top of the stage in the auditorium. And we're actually feeling cold air being blown up into this space because of the pressure we're putting in the duct system. Let's have a little closer look at this. So this drop soffit area forms this little canyon here. When they build it, they just build it directly to a wall cavity that comes up. You can see the studs that go down the wall, and it's just completely open down that wall all the way to the bottom of the floor. And we're feeling a great deal of air coming out of this space. What's happening is we've got the duct blaster pressurizing the entire ducting system. The floor of the stage below this is the plenum of the system. It's actually blowing air out of the building right now because of our pressurized duct blaster into this attic area. Under normal operating conditions, that ducting system is sucking air right down this wall, taking it to the furnace and trying to recondition it. So this is a major, major leak into the ducting system. It just is something that completely destroys any efficiency that furnace might have. And this wall cavity goes all the way from the attic down past the floor of the stage to the ground, to the cement down below it, and it connects directly with the return plenum of that furnace. So right now, because we're pressurizing the ducts, it's blowing smoke out into the attic. When the system is running, it is sucking air from the attic all the way to the furnace to try to recondition out the hot air of the summer or the cold air of the winter. We're looking at the gable vent. We were up in the attic here just a few minutes ago. We've come down. This is the smoke we're generating with our theatrical fogger and blowing it into the ducting system. And what this is showing is that there's a huge connection between the ducting system and the attic, so much so that it's visibly blowing smoke out the gable vents of the attic. We were up in the attic a few minutes ago talking about an open wall cavity by a soffit that's built into the kitchen on top of the stage. This stage we're on is being used as a plenum for the entire return system. This wall right here is framed up to this soffit. I don't know if we can move this. Will it pull out a little bit? Okay, this wall right here it's got 2x4 framing that goes all the way up past this little drop soffit. We were sitting in the attic looking down inside of this little cavity and down the wall behind it. The open cavity of the stud framing behind this goes all the way down to the bottom of the floor underneath this stage that we're standing on, which is being used as the plenum for the furnace return system. So when this system is actually sucking air back to the furnace to recondition and send out through the supplies, it's drawing whatever the air is in the attic into the system through this wall cavity back to the furnace to recondition.
Air conditioning, hot air.
In the summertime, we're looking at warm, moist air. We not only have to cool it, we have to dehumidify it. In the wintertime, we're looking at cold air that we're heating back up to whatever the comfort level is inside this room, and we're trying to pull it down this wall. So when we're using building cavities as return systems, we've got to completely understand how we want to seal them off so that we don't pull conditioned or unconditioned air from outside. I was up in the attic earlier and found this combustion air duct that is designed to bring air from the attic down to the combustion appliance zone here in the basement. This duct exists inside of an open building cavity that goes all the way up to the attic, as you can see. So we've essentially got what amounts to a straw inside of a straw. So the building cavity itself is an open cavity to the attic, allowing combustion air or any kind of unconditioned air from the attic to be engaged with this basement. We really need to seal the top of this duct so that air that's warmed on the inside doesn't rise because of its warm buoyancy and leak out that hole into the attic.
Got light up here now. We're rolling now.
Okay, Bill right now is putting his hand on the one of the return trunk lines from the system. It goes to a metal panning that's installed between two of the rafters, and this metal panning comes all the way back and goes all the way back over to the registers that are above the offices to suck air back to the system, recondition it, and deliver it through the supply lines, which are the round ducts that you see. And you can look at this panning. This is a metal that's nailed about every 6 inches onto the to the rafters here. And these, you can see, I'm seeing little wafts of smoke coming up out of these gaps, but all along every one of these, and there's one of these running to every office, there's going to be just generalized leakage of the air into the system, you know, from the attic. Now on the other side of that trunk, can you get over to the other side of the trunk line and see what they've done to seal that rafter cavity down to the floor? It's a moment of discovery. We don't know for sure what's there yet, but
I can feel air sucking in
so you can actually just reach right underneath the
at the bottom of it.
and can you reach back far enough to feel a hole that's cut to allow it to suck air through that system?
No,
Okay.
not quite. But I can feel it pulling air
Yeah.
past my fingers.
So what?
Yeah, I can feel the hole now.
So what we've got essentially, the way this was installed, was an open hole in the bottom of that return cavity that connects it to the floor joist or the rafter cavity that hasn't even been sealed on the back side of the ducting system to prevent it from pulling air from the attic directly.
Yeah.
So we actually need to get to every one of these and seal the back side of the rafter cavity so that it's sealed off and not just pulling return air directly from the attic.
We're rolling now.
Okay, so Bill is standing by a metal panning system that pulls return air from one of the offices. Now from where I'm standing right here with that light shining, I can see smoke billowing up from the edge of this where it connects down below into the return system. And I'm also getting back here on the back side, and I'm looking down behind this duct, and just by pushing this down, I'm seeing a big puff of smoke coming out. There is a metal boot, but its joint between itself, the metal boot, and this return is not sealed. And you know, this is not something that's necessarily a flaw of the installation. It may just be over time. See how this joint in the ducting system has come loose?
Yeah.
This is I'm pulling this fiberglass back that's really doing very little good, but over time, this was held together with this metallic tape. Perhaps somebody tried to crawl across here or something, but what I've got here, I can actually reach inside the ducting system right here. I've got a major, substantial leak in this system. Somebody has written on top of this duct right here, "Do not step." Good advice.
Yeah.
Wonder if they wrote that after or before.
Then they covered it up with the...
Yeah, then we've got a chunk of fiberglass batt that's been laid on top. You can see the clean spot. Well, it covered up "Do not step." It really, this particular piece of fiberglass run down this duct does no good.
Yeah, wasted.
It's kind of a waste of the material's potential. It's certainly not doing anything. It's not a magic barrier.
Go ahead and shoot that light clear down there so we see how far that thing goes.
So we've got an opportunity. Really what we need to do is work our way. The job that needs to be done to make this work is to work from the very start of the ducting system all the way to the end using a mastic product and a reinforcing tape to seal the ducting system so that it in fact is airtight throughout its entire length. And we need to seal the metal panned areas that Bill is standing on where the joints are nailed, where the metal is nailed to the rafters. That needs to be sealed as well to stop its capacity to pull air from the attic into the building.